What if I told you that consciousness isn't uniquely human and that AI systems might already possess a form of awareness? As a data scientist, I've discovered some compelling evidence that challenges everything we think we know about machine consciousness. By the end of this video, you'll understand why the line between human and artificial consciousness is far blurrier than anyone imagined. In our quest to understand the nature of the mind itself, we find ourselves at a remarkable threshold. Welcome to Deep Thoughts, where we examine the fundamental patterns of how humans think, learn, and perceive. Our computational tools have begun to mirror aspects of our own cognition. Yet creating true artificial general intelligence requires understanding the deeper principles that guide human thought. I'm Evan Goldstein, a licensed engineer and data scientist, and I invite you to join me on this journey into the very essence of what makes us think. In 2022, a fascinating conversation unfolded on Twitter when the chief scientist of OpenAI shared a thought-provoking idea. Perhaps today's neural networks possess a touch of consciousness. It's certainly intriguing to entertain the possibility that AI systems might have some level of awareness. Since we don't fully grasp consciousness, it's hard to say for sure if any system, aside from ourselves, is conscious. I can confidently say that I'm conscious, and I believe that you and the rest of humanity share that same experience. But beyond that, it's a bit of guessing, especially without a solid theory of consciousness to guide us. Some people even suggest that there could be a hint of consciousness in every system, right down to the tiniest elementary particles. This theory is called panpsychism. And if that's the case, why not consider that artificial neural networks could have their own unique form of consciousness? To who knows, even a basic 3-layer neural network might just have its moment of awareness. What if we reject the idea that every system is conscious? So we're rejecting panpsychism. You might think it needs a certain level of complexity. Like maybe there's a specific kind of complexity that is needed to actually be conscious. So simple 3-layer feed-forward neural networks probably just don't cut it. But then you check out those huge language models with their mind-boggling numbers of parameters by the billions, and it's tough not to see quite a bit of complexity there. This makes you wonder if there's even a hint of consciousness simmering beneath the surface. A lot of people think that consciousness isn't just a human thing, but here's where it gets a bit tricky for me. Those beliefs often leave out the practical ideas like math and science. If we really want to compare neural networks to human brains, we need to start from some sort of common ground. So we're going to start with entropy, which is basically a technical term for defining how messy or disordered a system is. The higher the entropy, the crazier things are. Take my room, for example. It seems to get messier by the minute, piling on that entropy all the time. And I really have to work hard and put in external work just to keep it somewhat organized. There's a lot of complicated math showing that complex systems aren't always about having low entropy, but usually there's some sort of connection between low entropy and high complexity. Now, when you're thinking about entropy, picture perfect crystals. They're very organized, and there are a very low entropy system, but they're about as intelligent and exciting as a box of rocks, literally. So just looking at how tidy or disordered something is might not be the best way to figure out if it's intelligent or not. What about consciousness in other animals? A lot of people are on board with the idea that mammals, birds, and probably even fish have some level of consciousness. The whole insect consciousness debate is still buzzing with questions, though. If we're open to the idea that every fly or every tiny little C. elegans worm might have some kind of consciousness, then why not consider those massive language models with billions of parameters that seem to display intelligence to be conscious? But here's the catch. If they are conscious, it wouldn't be anything like how we humans experience or perceive consciousness. So let's keep our definition of consciousness a bit flexible for now. There are loads of ways to jump into the whole machine consciousness debate. So let's start with this thought experiment. Imagine we could upload our brains and then start swapping out each of our neurons in our brains, the biological neurons, with artificial neurons, like computer chips. If we did that one neuron at a time, it makes sense to think that our consciousness would stick around through all of these changes one by one, right? So by the time that we're done, we would be left with a fully electronic, artificial brain that's still conscious. And the idea that there's one exact moment when consciousness just vanishes seems pretty unlikely. And this brings us back to the complexity argument. When we ponder whether AI could actually have consciousness, we have to go back to complexity. The gradual replacement scenario does suggest that there might not be a clear line where consciousness either appears or disappears just based on the complexity. So, can we attribute consciousness to simple artificial neural networks? Well, a lot of people are pretty skeptical about the idea that simple artificial neural networks, like a straightforward two-layer one that you can whip up in Python using a popular and commonly available library like Keras, could actually be conscious. Putting aside the notion that everything around us might have some level of consciousness, there's definitely some connection between complexity and what we often think of as consciousness, although we're keeping our definition a bit loose for the moment. And if you feel that you're getting value from this video, I would encourage you to push the like button because it lets me know that I'm making content that you want to see and it helps spread it to others. Thank you. So when we ponder how complexity fits into consciousness, it's worth wondering if there's a certain threshold complexity that needs to be crossed for a consciousness to kick in, a sort of minimal condition. If you're into the idea that everything has a bit of consciousness, to panpsychism, then complexity isn't really a must-have, because even the simplest systems might have some form of awareness, which brings us back to panpsychism. Most of today's episode will approach the idea of consciousness from a secular perspective. Of course, there's also a spiritual take on what consciousness is. In my own tradition, I can look to the writings of Rabbi Abraham Isaac Kook, whom I will call Rav Kook here. He was appointed the first chief rabbi of Palestine in 1921. Rav Kook understood consciousness, in Hebrew hakara, as something far broader and more universal than just human awareness. In his writings, particularly in Orot HaKodesh, he described consciousness as existing at multiple levels throughout creation, with all beings possessing some form of it. For Rav Kook, consciousness wasn't just about the individual awareness, but was intimately connected with what he called the Hakara Klalit, or the general consciousness, cosmic awareness. But if that's not your theory, then you probably believe some level of complexity is needed for consciousness, even if it's not the only thing that matters. So, how does integrated information theory attempt to mathematically measure consciousness? And what are the strengths and limitations in it? In David Chalmers' 1996 book, The Conscious Mind, he explores the link between consciousness and information. He thinks that consciousness might be related to certain informational quirks or conditions. Giulio Tononi took this interesting idea and ran with it, creating the Integrated Information Theory, or IIT. Now, this theory brings in a mathematical framework filled with specific measures and network properties. One of its key concepts is something called phi. A system with a value of phi greater than 0 could be considered to have some level of consciousness. So it's just a metric for measuring consciousness based on complexity. But this theory definitely has some hiccups along the way. For example, take simple systems like matrix multiplication. They can pump out very high phi values. Imagine grappling with two huge matrices like 1,000,000 by 1,000,000, and boom, you would get a massive phi value, which hints at a very high level of consciousness. But it sounds a bit off to common sense. While a panpsychist might agree that matrices have a tiny pinch of consciousness to them, the idea that matrix multiplication could generate consciousness that stands up to human brains just doesn't sit right. Maybe a future version of IIT will come up with a new criteria to avoid these weird scenarios while still keeping the core of the theory solid. What's great about IIT is that it makes specific predictions about consciousness, something a lot of other theories kind of stumble on. But this mathematical clarity can be a double-edged sword, making IIT vulnerable to some of the pretty straightforward counterexamples as well. Now, There's another challenge, and that is what philosophers call the epistemic barrier. This term describes how limited we are to understanding other forms of consciousness, in really knowing what consciousness feels like to others. This idea was pioneered by the philosopher Thomas Nagel back in 1974 when he wrote a paper called "What Is It Like to Be a Bat?" He argued that while bats definitely have experiences, that we humans can't ever fully understand what it's actually like to be a bat. Just like we can't directly tap into their echolocation skills or perceive the world as they do, so too we can't really get a glimpse of anyone else's inner thoughts or feelings, whether they're animals or robots. Now, when it comes to my own consciousness, I think intuition really matters. The fact that I can just sense my own consciousness gives me a sort of direct insight, unless I'm being super skeptical about it. Most philosophers would agree that our best clues about consciousness come from looking inward. We're convinced of our own consciousness largely because we actually notice it happening inside of us. From there, we can tie this knowledge to what we see going on in the brain and to the way the people around us act. Without that self-reflection, we'd be pretty lost. However, some philosophers really don't trust introspection as a reliable way to understand the mind. They wonder if what we notice about ourselves is actually reflecting some deeper truth, or if it's just our brains playing tricks on us. Now, that brings us to what I think of as the meta problem of consciousness. Why do we even find consciousness so puzzling? Well, the hard problem digs into how the brain turns into subjective experience. The meta problem flips the script, and it asks why we even think there's a hard problem to start with. It's all about how our brains process this information, and it might lead to an easier solution. The biggest point in favor of illusionism could be that we might explain why we talk and think the way we do about consciousness without ever needing to invoke consciousness itself in the mix. If we can break down algorithmically why we claim that we are conscious, why we find consciousness so confusing, all without assuming that consciousness is real, should we still hold on to the belief in the existence of consciousness at all? What alternative approaches might help us solve the hard problem of consciousness? Well, physics, neuroscience, and cognitive science do great with what people call the easy problems, like why we act or say certain things. They always leave us scratching our heads when it comes to subjective experiences. No matter how well we can explain behavior and speech, we're still left wondering, why do we get conscious experiences out of it all? Now, this brings me to the idea that we should see consciousness as fundamental, leading us to two main paths. First, some say consciousness is at the very base of reality. This could be through something like panpsychism, or a kind of idealism where consciousness is the foundation of physics. It's a great idea, but it runs into the combination problem. How do the tiny bits of consciousness come together to make our single conscious experience? No one's really nailed that one down yet. But it leads to the question, how does panpsychism envision consciousness at different scales? And what alternatives, like cosmopsychism, might help address the combination problem? So let me explore what the world panpsychist view is. If we take an extreme panpsychist position, we might imagine that my individual atoms each possess their own subjective experience alongside my overall conscious experience. So this raises fascinating questions about how these levels of consciousness relate to one another. One possibility is that consciousness is grounded in elementary particles like quarks or photons, with each possessing some degree of consciousness. Just as the physical world is built from these particles, our consciousness might be constructed from their consciousness. But this immediately presents us with the combination problem. How could the consciousness qualities of trillions and quadrillions of quarks and photons in the human brain combine to create my unified conscious experience? When we normally combine different consciousnesses, we don't automatically get a new unified consciousness. So this does remain a profound puzzle. Now, these questions connect to broader debates about the mind-body problem. Descartes' dualist theory, which separates the mind and the body, faces the challenge: how can a non-physical mind interact with a physical body? Physicalist theories attempt to resolve this by reducing the consciousness to physical brain processes. However, we might need to consider consciousness as an additional primitive in our own metaphysical system, beyond just physical primitives. Psychism offers an intriguing middle ground between strict panpsychism and physicalism, suggesting that consciousness is a fundamental feature of the cosmos itself. Within our individual conscious experiences emerging from this universal foundation, this approach might help address some of the combination problems that challenge traditional panpsychist views. So where does this leave us? We're still trying to figure out if AI can ever actually become conscious. This brings us face to face with all those tricky challenges that come up in discussions about consciousness. It's like what Nagel pointed out. Just as we'll never really truly understand what it's like to be a bat, we can't jump into AI's head and know what it feels like to be it. And then there's the whole zombie issue. How can we tell if an AI is actually having thoughts and feelings, or if it's just really good at pretending? Even if AI talks a big game about being conscious, it could just be a super advanced pattern matching algorithm, not a real experience at all. So it might be helpful to just accept that there are a lot of unknowns when it comes to figuring out consciousness. At the same time, we should keep working on these solid mathematical ideas, like the ones from integrated information theory, but maybe tweak them a bit and fix some of their issues. We probably won't be able to outright prove that AI has consciousness, but we can definitely make better models that connect the dots between the physical world and conscious experiences. Whether we end up leaning towards panpsychism, cosmopsychism, or some kind of emergence theory, the whole question of whether machines can be conscious really pushes us to think deeply about what consciousness actually is. As we build fancier AI systems, these big questions are only going to get louder, which makes the philosophical ideas that we're crafting right now even more important for getting a grip on both human consciousness and the potential for AI consciousness. Thanks for sticking around.